All right, let's do example 8.53 here. So 8.53 says Pluto and Charon. Pluto's diameter is approximately 2,370 kilometers, and the diameter of its satellite Charon is 1,250 kilometers. Although the distance varies, they are often about 19,700 kilometers apart, center to center. Assuming that both Pluto and Charon have the same composition, and hence the same average density, find the location of the center of mass of this system relative to the center of Pluto. All right, so you see those two pictures. Those were taken by our last New Horizons spacecraft that went past Pluto. Took those nice pictures. So we know the diameter of Pluto, the diameter of Charon. Charon is very large relative to Pluto. Now we on Earth also have a very large moon relative to our size, not quite this dramatic though. And then the distance center to center is 19,700 kilometers, and they did tell me that the densities are equal. Now I know that mass is density times volume. The volume of a sphere is 4/3 pi r cubed, and so I can talk about the mass as being the density times 4/3 pi times diameter cubed over 2 cubed. So as I substitute in d over 2 for radius, that's what I get. And I want to find where is the center of mass of this system. All right, so I set up my center of mass equation. I'm going to choose the center of Pluto as x equals 0. Whenever you find a center of mass, you need to choose a location where x equals 0. For me, that's kind of nice because that gets rid of that term in my equation. And so now I have xcm is equal to m2 r2, where r2 is this 19,700, and m1 plus m2. Now you might argue with me that we only know the diameters, we do not know the masses. Well, what I'm going to do here is I'm going to make that substitution there for all of that stuff. And so I have the density times 4/3 pi, and then I have the 1/8 times r of Charon cubed, oh my goodness, times r2, all divided by density of 4/3 pi 1/8. M1 was Pluto, so radius of Pluto cubed, plus, you're probably seeing what's going to happen here to all these densities, 4/3 pi's and 1/8, yeah? R cubed of Charon. So I see that this term, this density 4/3 pi times 1/8, this is all going to cancel for me. And so I'm going to be left with xcm is, oops, these were supposed to be diameters, weren't they? Oh well, we'll fix those. Diameter of Charon, diameter of Pluto, diameter of Charon. Good catch on that if you'd caught it. So I have the diameter of Charon, and since these are all in common units, if I can keep them all in kilometers, we're good. And then I'll end up with an answer in kilometers for my center of mass. So I end up with 1250 cubed times 19,700 divided by my 2370 cubed plus 1250 cubed gives me an xcm. So the location of the center of mass here when we calculate is 2,520 kilometers. Well, the diameter of Pluto is only 2370. So if this is the radius, it's more than that far out. So that location of that center of mass is outside of Pluto significantly. And so what that means for me is that these two objects don't actually, this moon doesn't actually orbit Pluto. Pluto and the moon themselves orbit a common point in space. And this is the reason why Pluto lost its planetary status, because it does not dominate its space gravitationally. It still has Charon influencing that gravity. There's also a lot of other debris out there as well because of Pluto's size. Now, for comparison, the Earth has a radius of like, what was it? It was like 6,400 kilometers, something very close to that. And the center of mass for our, which relatively large moon, is just a 4,700. So right about there is our center of mass, still inside of the Earth. And so the moon does technically orbit us. It does, however, orbit a point kind of in our outer, maybe our mantle area there. Okay.